aerospace and defense manufacturing,
machines and automation,
additive manufacturing,
smart manufacturing,
global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing. Visit us at sme.org.
Today's episode is sponsored by our guest.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Amy Bryson, contributing lead editor of Smart Manufacturing Magazine. Today we'll be discussing some manufacturing blind spots and how to leverage a smart manufacturing architecture to be more resilient and profitable. And joining us today is an excellent guest for this topic. Rob Shainthaler is Chief Revenue Officer at ThinkIQ, and ThinkIQ is a leader in transformational intelligence for manufacturers. They contextualize data both in plant and across your supply chain to help improve yield, safety, quality, and compliance. Now, Rob brings more than 25 years of experience in enterprise software, big data analytics, IIoT, operations strategy, supply chain, and large-scale program management to ThinkIQ, where he currently helps customers adopt the right software to become more competitive and profitable. So thank you so much for joining us, Rob, and welcome to the show.
Great. Thanks so much for having me. Appreciate it.
You got it. And before we dive into our topic, Rob, can you give our audience just a bit more background about you and what you all are doing over there at ThinkIQ?
Yeah, sure. So me personally, as kind of said in the intro, I've been spending most of my career in the manufacturing and supply chain space. Started on kind of the consulting side and then moved over to the dark side of software early 2000s, and I've been doing kind of cloud-based enterprise software since about 2005, I guess, helping customers select, implement, and get value from cloud-based technologies. At ThinkIQ, my responsibilities as Chief Revenue Officer include basically pre-sales activities all the way through, getting someone to sign up as a customer or add to their capability set as an existing customer, and then also make sure too on the kind of the customer success side that they're getting value out of the solution. Based on the West Coast here in Nevada, up near Lake Tahoe, bounce around the world, actually, not even just the U.S., meeting with customers and helping them learn how to leverage smart manufacturing capabilities like those we have here at ThinkIQ.
Great. And what size customers do you usually deal with? Do you deal with small and mid or primarily large OEMs?
Oh, good question. So one of the things that we're quite proud of about our technology is that it can start very small and then grow as needed. And part of that lets us serve both small and large manufacturing organizations. We've got, some SMB type single roof, small manufacturers, family-owned businesses that use the same technology as, some of our largest customers, like a General Mills uses, right?
Oh, that's great.
And part of that comes from, the benefit of being able to leverage cloud, right? Where the infrastructure can scale as needed. For us, that allows us to address manufacturing problems for both small and big. We focus most of our energy with larger customers directly, but then we do work with organizations like SESME, the Smart Manufacturing Institute, and more working with a lot of the MEP organizations around the U.S. To kind of get that outreach done to the smaller folks who are sometimes a little trickier to reach for a software company like us.
Yeah, I know we'll talk a little bit more about that in a minute, but let's first talk about, what are the manufacturing blind spots? You spend a lot of time working with customers. You've talked to, a range of size customers, different stages of their, maturity in terms of, where they are in their digital transformation. What do you think are some of the biggest blind spots right now, and how can those be filled?
Yeah, well, so the way we like to look at it with our customers is, we're coming in to talk about smart manufacturing, Industry 4.0, digital transformation. They're all somewhat similar, right, in terms of kind of the intent of applying technology to solve industrial problems. And what I often find is we as a software provider ecosystem, and as well people looking at the space, I think sometimes overcomplicating up front and are looking to have AI solve every problem or something, right? The reality is if you can't manage what you can't see kind of paradigm, right? First, we like to say is where are the problems and challenges in your business, and where do you have blind spots that go along with this. And what we mean by a blind spot is an utter lack of information about the area. So if we think about the smart manufacturing context, we spend a lot of time talking about digitization, which is important to get data. We'll talk about smart equipment. We'll talk about automation, super important. But there's a whole spectrum that we are kind of ignoring, I think, or we don't, but most people do, which is some of the really tricky bits that need to be managed, but aren't kind of conducive to that type of digitization. Simple example, manual assembly processes, right? We have a lot of customers where their blind spot is why they're not producing as much finished goods as they expect in final assembly. And maybe they're a high mix environment, right? So it's not like same thing over and over again, making a widget. And so there's a lot of complexity and variability, and they don't know what's going on. We had one small customer. We started talking to them and they're like, well, we've got some automation over here that's working okay, but what's killing us is final assembly. I'm like, well, what do you mean? They go, well, we're not making enough product. I know that. Like, I guarantee we're not making enough. The only data I have is how many units we produced and how much payroll we paid. like between, other than that, I have no data. So that's what we would call like a blind spot, right? We also see cases where, maybe there's been a lot of focus on getting information from a factory floor, but when you kind of look at the gazins and gazouts of stuff coming into the factory and stuff leaving the factory, that's often an area too, where you kind of look at inbound materials and outbound supply chain. Often that becomes a bit of a blind spot. Maybe we have shipping records, but exactly what went on as that was happening. Where did stuff flow as it came into my factory and get put on shelves? Some of those kind of things a lot of people are completely blind to as well. It could be really important if you're dealing with a traceability or quality problem, for example, right? Of kind of where stuff came from. So those are a couple of examples of what we might call a blind spot.
Great. Now, you mentioned at the top of our discussion that you're working with SESME, and for those, I'm sure, who the maybe one or two on listening don't know who SESME is, a Smart Manufacturing Institute, focusing heavily on the importance of having an information model as a foundation for a smart manufacturing architecture. Can you talk a little bit about, why they emphasize this and, why it's important?
Yeah, it's the Smart Manufacturing Institute has been around 6 years now, I think, in its current kind of form. And before that, it was called the Smart Manufacturing Leadership Coalition, but been around quite some time. And for those who aren't familiar, kind of government funded through the DOE, but it's a public-private, kind of partnership where corporations will work with SESME on a research project, right, to tackle a particular manufacturing problem or come up with new capabilities. But a big part of their charter is advancing standards and requirements for what a proper smart manufacturing technology architecture and platform should look like, right, to really achieve kind of the vision and intent of bringing smart manufacturing capabilities to the manufacturing sector. And one of the things that's most unique in what SESME has been advocating, and then what we have brought to life here at ThinkIQ with our technology in working with SESME, is this idea of information models. And what do we mean by that? It's almost like a template about what is important to collect, understand, and analyze for any type of manufacturing process or piece of equipment, et cetera. And what it's trying to tackle is a lot of the Industry 3.0 legacy that has driven so much incredible cost and complexity. Primarily, if you think about like the automation sector, where we'd spend a lot of money putting controllers in and having people program each controller. First of all, a lot of environments don't even have that kind of equipment, but when they do, it was very, very expensive. And what we kind of look at today, what we're left with is each person that did work, the way that the data kind of was designed and structured was what they thought it should be, or what maybe that company decided they wanted it to look like. But when you start looking at doing that repeatably, scalably across supply chains, it kind of falls apart really quickly, right? Because you're redoing it every time. And then the other thing we see too is within a company, the different constituents, like the people focused on, process engineering and quality, have needs from data. Folks that are worried about the maintenance, let's say, right, of the equipment, have another set of things they care about. And then we've got folks just running operations, right, like hitting targets and stuff. So 3 different organizations that have different needs. And they may have some data coming from a piece of equipment that's important to each of them for different reasons, let's say, right? But what would happen in the past is each team would go about their own exercise of trying to go get that data. Well, what information models bring to the table is this idea of a standardized approach to what the data should look like, what's important, and make sure that all the constituents that might benefit from it are able to go to one place and get it once, reliably and predictably. The other piece they're trying to tackle is context to the data so that it makes sense, right? It's useful information. And the biggest example I would give there is if you look historically, all of that data we would collect about manufacturing was very hierarchical in nature. It was equipment centric in terms of I have a piece of equipment on this line that's part of this plant, right? And it was very hierarchical. So the only real view you had of data was a hierarchical equipment view. Now, let's step back for a moment. What do customers pay manufacturers for? They don't pay them because they have a fancy new cobot in their factory. They pay them because they make a good, high-quality product, right, at a fair price. But fundamentally, the value stream that manufacturers should be focused on is the products they are producing to sell to customers, right? Why, then, is the only way we can look at the data a hierarchical view of equipment? Makes no sense, right? So if you think about truly driving useful analytics with manufacturing, let's follow the money, let's follow the value stream. Well, okay, let's think about that for a second. So if I want to understand why I have poor yield for a part that I'm making on my plant floor, well, what are some of the typical root causes? There might be a supplier incoming material quality problem, right? We might have a worker training problem. We might have settings wrong on a piece of equipment, right? Maybe someone didn't set the machine up correctly and stuff's going through it and it's actually messing it up along the way. So we could have a material issue, we could have a people issue, or we could have an equipment issue, theoretically, right? Well, if the only context I have is a hierarchical view of equipment, it's really hard to suss out a root cause in that scenario. So the other thing that comes into play with information models is this concept of applying graph relationships. My simple analogy is it's kind of like Facebook for industrial supply chain or manufacturing. So we're all used to social media paradigms. Somebody wants to advertise to me, so they don't just care about me and how old I am and my ethnicity and where I live. They also care about who I am friends with, what car I own, right? They think about the relationship between me and other things too. So in the manufacturing paradigm, same concepts, same technology actually, right? But the things we care about are different, right? So who did we buy the raw materials from to make this product? Who was working at that time? What is their training? Have they gotten all the training and certification they need to do this? What were the equipment settings when this part went through the equipment? Those are very different questions, right, than feeds and speeds of a piece of equipment over a 24-hour period. So by having the information models and a graph relationship capability, we're now able to understand multidimensional relationships between kind of all the physical things that go on in a manufacturing supply chain. Back to the old, people, materials, equipment. Those are the three major types of physical things we need to worry about. So if I connect that concept now back with blind spots, great, I want digital data. Maybe we've got a good way to get data off the equipment. How do I get data about incoming materials other than I purchased them? How do I get information about who was working on it or how much time was spent working on it? So that's another part where we try to bring all this together, a contextualized understanding of what's actually happening, in terms of digital twinning, but with context that's easy to understand. You don't need to be a data scientist or a programmer to understand it. It presented in a way that's discoverable and understandable by an operations person. And then the ability to fill in blind spots. And we can fill in blind spots a few ways. If there's not equipment that I can get data from, we can put sensors on things. There's a lot of great, simple IoT sensors that we can, quickly deploy these days. CESPI's done some great work and us with them to make them available and pretty much plug and play with our technology platform. And then ThinkIQ uniquely has a capability called ThinkIQ Vision, where we can use any camera. We often provide them, but we don't have to. We can use existing cameras. And we basically can turn pictures and videos from a camera into data continuously. Just like if a person was there writing down as fast as they could on a Big Chief tablet what was happening, kind of a time and motion study. But, we do it with cameras and software, and never takes a bathroom break, never goes to sleep, is completely objective, never forgets anything, right?
Yeah.
It would be foolhardy to say, hey, Amy, please go watch that constantly and tell me what you see. Like, it's just not a way you can realistically run a factory, right?
Right.
But we bring that capability in. And so what we find is you go into a manufacturer now, discuss their manufacturing challenges in their terms, right? Where are you struggling, and what do you believe the problems are? And then we're able to come in with digitization strategies that provide them answers to the why they're having problems quickly, easily, and without a lot of preconditions about modern equipment must be there first. Do you run this version of something? We don't care. And we find that people really appreciate the fact that we're able to focus more on their world versus ours, right, in terms of helping them. And then we want to go for quick wins. And so we, a lot of folks, as they go on a digitization journey, will do, proofs of concepts or, phased work. A lot of it feels like agile development in software, right? You kind of do small, quick sprints, right? Well, we're able to work with manufacturers in a similar way there too. So now back to one of your earlier questions, big companies, small companies. A small company, you might go in, do a first sprint, if you will, and that's it. That's the end of the journey because they're small. They only have a little bit of stuff they need to digitize. Go to a big company, right? They've got multiple factories around the world. They interact with each other. They may want to digitize suppliers' interaction with them, stuff with customers. They may have much more sophisticated analysis they'd like to do. So that journey with a big organization may go on and on and on, right? But the same technology is helping both small and big companies. And that's one of the ways that, our work with Sesame, we think is going to kind of rise all tides, right? Because they're using the same capability set, right? So as the bigger companies might advance things, or maybe there's a Sesame research project to push forward something, it's instantly available to everybody that's trying to leverage these technologies that we bring to market.
Yeah, I think that's important, especially for our listeners who are always looking for prescriptive guidance related to digital transformation, which is a daunting journey for many. And it sounds like the work that ThinkIQ is doing and on its own and in collaboration with organizations like Sesame, is proving out that smart manufacturing strategies can be implemented in manageable increments, right? And you can kind of quantify or demonstrate results at each step along the way. So it breaks it down, disassembles it into a little bit of Lego, pieces. And I think that's helpful for people to understand that, you're attacking specific problems. You're helping people understand what the real problems are, and you're addressing it from the problem, not the technology.
It's a great way to put it, right? Problem-centric, not technology-centric, right?
Yeah.
And I think people rush to the technology first too much, and we really need to always step back and really focus on what is the manufacturing challenge that needs to be addressed. And let's not be the smartest people. Let's be the most pragmatic people in helping to address that problem, right?
Right, yeah.
And there's another dimension to something you just said there, Amy. So when you think about doing things incrementally, there's two parts that I find valuable to manufacturers of thinking incrementally versus, kind of big bang, large projects, right? Mm-hmm. One is reasonable investment, and investment is not just dollars. Time is typically the most precious asset for the manufacturer, right?
Yeah.
So a reasonable investment of their time to see benefits, that's one thing. The other benefit I see coming from kind of iterative approaches like that is the reality is the biggest problem you need to tackle will change from quarter to quarter. Well, sometimes day to day, who are we kidding? But realistically, right, when you think about a journey, the journey is going to be disrupted by things that are outside of your control. And there's another benefit, I think, right, to working in chunks so that you can course correct to align efforts with business priorities with a reasonable cadence too. It's not typically the one most people think about, but I think it's one that's really, really worth keeping in the forefront of thinking of, how you go start adopting technologies like these. And kind of the pace and cadence with which you do it.
Yeah. And speaking of how things kind of change and ebb and flow, right now we're in an interesting time where smart manufacturing technologies are, expected to play kind of a critical role in driving sustainability efforts in manufacturing. What do you think, is important for our listeners to know about what's happening with, greenhouse gas emissions, disclosures, and the SEC's proposal to, net zero economy by 2050? I mean, how are you seeing this impact manufacturers to find new ways to cut their emissions and increase their sustainability initiatives that are no longer kind of a nice to do for, brand halo effect, but, a business imperative and there could be fines associated with it?
No, it's really, really good question. So, I think there's an element where some companies have chosen to really focus on being green as part of their brand, right?
Mm-hmm.
Apple comes to mind. They very, very outwardly talk about work they're doing to redesign products, right, to be carbon neutral. So not everybody has so far. But what's interesting about what's coming now, of course, is a compliance exercise where you have to report, right, if you're a public company, to the SEC, scope 1, 2, 3. Scope 1, there's stuff you do directly. 2 is, kind of tightly controlled by you. 3 is your supply chain, which is really tricky, right, kind of outside your direct control. And what we're excited about, we're excited about a couple of things. Number one, we're excited that there's a forcing function now to make people look at their emissions because they have to report them. Now, some companies, that may be enough, right? They're going to check the box. They're going to be compliant. What we're more excited about are companies that actually want to leverage the fact that this is now required to embrace it and improve their impact versus just report it, right? Now, as we work with manufacturers, one of the things that we have in our platform that's quite unique is called the Material Ledger. It's actually patented, but we use all of these relationships I talked about earlier, right? Of kind of how equipment is related to people and materials, how do things move through the process of producing the products. Under the covers, we have a capability that can automatically keep track of everything that's happening in what we call a material ledger. And it's just like a financial ledger, but instead of following the rules of finance, it's following kind of the rules of physics, right? Oh. Materials move from place to place, they get transformed, things have to kind of move through. And it's not because people are typing, it's the system is able to interpret all of the data that's coming into it and then construct this representation of how things are physically moving through all of these activities, including transformation from one form to another, all sorts of really fascinating stuff. Well, we've now taken advantage of that same capability to interpret data signals and turn it into this representation of materials moving through. We can now do greenhouse gas emissions using the same capability set. So, for example, if we know what material you bought, well, we can represent the material in the platform. We can either have a standard specification of what is the embedded carbon when that roll of steel shows up at your dock, or the steel supplier could share the provenance of that specific roll of steel with you. Either way, we can take that as an input. So now we know the roll of steel's embedded in carbon. As that roll of steel is cut up, sliced, transformed, moved through the process, we can now add onto it as it moves through and aggregate all of the greenhouse gas costs for each product you're producing behind the scenes just by doing a little bit of configuration and setup and modeling out. So we call it modeling out the representative things you need to understand. We have an engine that can calculate this all the time. And so if you just want to be compliant and report it, you could probably do it manually and look at your electric bill and make some assumptions and produce stuff. But we're working with customers that really do want to understand it at a fine grain level. But the fact that our system can just produce that analysis as a byproduct of doing its primary work on your manufacturing activities, people are really appreciating because it's not an extra initiative suddenly, right? I'm getting benefit from my manufacturing operations and understanding how I can reduce my greenhouse gas, emissions simultaneously with a common set of analytics that are tightly tied.
And they should be, because I just can't imagine that this is going to become any less important, right? So for those people who are doing something now, and it sounds like such a turnkey way to start to have really valuable insight, data-driven insights to be able to not only understand it, but report it, which is, going to be mandated in so many different ways. I mean, now is the time to get smart with that and to find, a solution that will work with you and scale with you, because I think that's important.
Oh, yeah, for sure. Right. And it's like many of these things, if you get ahead of it, right, it makes it so much easier later to evolve and extend capabilities as things will change. Back to our earlier discussion.
Yeah.
But, kicking the can down the road, at some point, it is going to become this big, heinous project if you don't get ahead of it. And we're excited that we're able to help customers start tackling this. We feel, good about it, and in a true sense of the word, that we're making an impact there. And being able, especially for manufacturing companies, which is the world we live in, here at ThinkIQ, manufacturers consume a huge amount of energy and produce an enormous amount of greenhouse gas emissions, right? I mean, just as a sector, it's pretty significant. So being able to help our customers get good at understanding, managing, and ultimately reducing their carbon footprint is something we're excited to be doing.
Absolutely. Well, I know we've covered a lot today on this conversation. And is there anything else as it relates to some of the manufacturing blind spots that you want our listeners to know that they should be aware of for 2024? I
mean, I guess my biggest thing I'd say is it's not as hard as you think. And I think a lot of folks are intimidated by all of the gobbledygook tech talk and stuff. The reality is it can be very simple and approachable. We've got customers who have zero IT staff, who have nobody that can spell data science, getting benefit from our solutions, in very complex ways in manufacturing environments that they didn't think could be digitized, right? So does not require special skills, not a ton of money, most importantly, not a lot of time. So that's probably the first thing I'd say is it doesn't need to be that hard. So don't be too scared. And I think the other thing is you got to try stuff, right? My experience has been now you could try to research and all these things. Reality is you're better off trying some things and experimenting in this space. And if you haven't already, kind of get going on it. And maybe that can be your New Year's resolution for 2024, right? Is we're going to actually bring some smart manufacturing capabilities into our factory and start putting some goals around what that might look like for your organization.
That is sage advice. Well, Rob, I want to thank you for taking time to join us and sharing those valuable insights with our listeners. And if people want to learn more about the work you and your team at ThinkIQ are doing, where should they go?
Easiest place is to go to our website, thinkiq.com. So THINKIQ.com. Lots of good information there, including, by the way, we were chatting about the greenhouse gas. We've got a wonderful white paper that helps educate people a bit more on what is it they need to worry about when it comes to reporting and some of the techniques to solve that. So we've got some good educational content on that particular topic as an example of something you might find there.
Yeah, I was checking out your website over the break, and there's some wonderful resources on there. So make sure you take Rob up on his offer and go download some of their content and use it for all of your initiatives in 2024 and beyond. And Rob, thanks again, and thank you to our listeners for tuning in. Make sure to stay up to date about what's happening in manufacturing and hear more podcasts by visiting us at sme.org.